Okay, for this one, we're going to go back to um, Theorem 2. Theorem 2 from 1.2 says ax equals b has a unique solution if and only if there are no free variables. Okay, so it can't be a free variable. Okay, therefore, so no free variables means the matrix A has a pivot for every column. Okay, you'll remember that a free variable occurs when you have a non-pivot column. Therefore, A has 3 pivots because A is 3 by 3. Okay, it's got 3 columns. Therefore, A has a pivot for every row. And if I have a pivot for every row, therefore, if I have a pivot for every row by theorem 4, the columns of it's not an A span are 3. Okay, that's difficult, not arguments. I had to go back to theorem 2 from 1.2, and I also had to do a bunch of reasoning here, and then I had to use theorem 4. Okay, this takes some getting used to, but don't be freaked out if you can't follow that the first time. Okay, wrapping up 1.4 now. What do I want to say? Some useful properties of oh boy, of the matrix vector product. Okay, the first one is you have a distribution. Okay, it does distribute the way you would want it to. 2, if you have A times a multiple of the vector. Okay, you can move that multiple out front. Okay, this is useful, especially because if you have something like 6, 7, minus 1, 3 times a vector that is, kind of unpleasant, right? Let's see how that. Okay, you should avoid big numbers like this if you can. So what you would do is you go 6, 7, -1, 3, and then you would factor out a 3, right? No, you factor out an 11. You do factor out 11, and you get -3, 6. That makes your life a lot easier because the 11 can move out front. Maybe put brackets here. Okay, so I hope I'm not going to finish it, but the idea is that, I don't have to work with such large numbers if I make use of this property.